Hey everyone, it's Mr. Oda. In today's video lesson, we're going to be going over topic 4.3, soil composition and properties. And so in this video lesson, what you're going to learn is how to describe the similarities and differences between properties of soil types. And for your skill, you're going to describe an aspect of research method design and or measure being used. So to start, we're going to first talk about what kind of soil you can work with. And there's essentially three different types of particles that can make up soil, and that would be sand, silt, and clay. And each of them have their own unique characteristics, and they're even more unique when they are combined. First thing you need to know is that the different particles are very different in terms of size. Although it might not look like it, sand is actually the largest of these particles, where silt is the middle and clay is actually the smallest particle of the three. Another big difference between them is their water holding capacity. The larger a particle size is, it actually allows water to pass through it easily. And as you guys have probably seen from when you've gone to the beach, if you have, sand does not hold water. Water passes straight through it. However, when you have a smaller particle size, it will not allow water to pass and therefore hold it very well, which would be clay. The image on the right shows an example of this. If you poured water through a mixture of soil, 100% silt, I'm sorry, 100% sand, the water will go through it in an hour. If it's silt, the water will pass through it in 100 days. If it's 100% clay, the water will pass through it in 100 years. Clay does not allow water to pass through it at all, or not very quickly. And this is another example. If you pour water through it, 2 hours for sand, 200 days for silt, 200 years for clay. Sand is the most permeable between all three, and clay would be the least permeable. And the reason for this is because sand has more pore space or porosity. Because the particles are so large, they have so much more space between them, so they can't hold onto the water. Whereas with clay, since they're so small, they are stuck together very tightly, and they prevent water from passing through. And silt is, of course, somewhere in the middle between those two. Now, how do we apply this to looking at soil? Well, you can measure any soil and its composition because soil is usually a percentage of all three types. And the way you do this is by using this soil triangle. As you notice on here, it has all three types: sand on the bottom, clay on the left, and silt on the right. By knowing the percentages, you can figure out what type of soil you are working with. So as our first example, we have 25% sand, 30% clay, and 45% silt. What kind of soil is this? So we're going to model this first. When you look at this, you want to find, you're going to take one of the values, so 25% sand, and you're going to find it on the triangle. So we're going to look for sand at the bottom. We're going to find 25, which is between 20 and 30. And you're going to notice that the numbers are curved a little bit, which shows what line you should follow. So 25% sand is right here, and I'm going to do my best to draw a line across this on the soil triangle. So we're looking for somewhere on this line. I know it's not straight. I'm trying to write with a mouse. I apologize. Then we have 30% clay. So we're looking on clay. The numbers are horizontal, so we're going to be following this line right here. So again, 10, 20, 30, 30% clay. We're going to start here, and we're going to do my best to draw a line across here. All right. Now, you could stop there because you already are kind of seeing where they intersect. But let's go with 45% silt. We go to silt here. We look at all the numbers. We find 45. And we notice that the numbers are tilted downwards. So we're going to follow this line. Okay. We draw those lines, and they are intersecting right around here. And that would be what we call clay loam. And that is how you would find out what type of soil you are working with. Now, let's see if you guys can do it on your own. What type of soil would consist of 60% clay? I'm sorry, 60% sand, 30% silt, and 10% clay. Try that question on your own. Okay. And so when we look at this again, we're gonna use the rules that we just learned. 60% sand, I'm gonna find it right here. I'm gonna draw a line across right here. 30% silt, we're gonna look at silt over here. We're gonna find 30%, and we're gonna draw a line straight down or at an angle. Okay. And the good thing about this is that if you know your percentages of at least two, you could find the answer because we've already seen where they intersect. But you could use 10% clay to find the line right here. And they all intersect at sandy loam. And that is how you would find that answer. Now, let's do a little bit more practice. What would the percent sand, silt, and clay be for soil V? Find soil V on the diagram and write down the percentages for this soil. Hopefully that question was easy for you. Now, to continue on, when you're looking at soil, you can test for a couple of different things. One of the most important tests for soil is chemical. So soil is going to have chemicals that are important for plants, such as nitrogen, nitrates, phosphorus, as well as what the acidity level is. These chemicals allow plants and animals to thrive there. Uh, Now, if there's not enough of something in soil, what you can do is add that through fertilizers. So a lot of fertilizers will have N, P, and K inside of it. And some fertilizer and even rainfall can increase the acidity level. And the images that you're seeing here were taken from our school. Basically, what you can do with soil is mix it and test to see what kind of nutrients are found there. Additionally, you can do a physical test, which is what we've been practicing just now, where you're going to see what percent sand, silt, and clay is there. And when you do that, you can figure out the water holding capacity, which we call percolation, the movement of water into the ground, and infiltration, which is the movement of ions through the process of percolation. So again, this has to do with how permeable the soil is. If it's sand, if it has a lot of sand in it, the water is going to run through it very quickly. Now, when you're looking at this, by mixing it with water, you can see the separation of the particles. In this person's example, you have 65% sand down here, 29% silt, and 6% clay at the top. Okay. Now, using that example, I want you guys to try to find this. What kind of soil would this be if we have 65% sand, 29% silt, and 6% clay? Right? And now that you found that, what conclusion can you make about the water permeability in this soil? Look at the percentages. How well would this soil hold water or release water? Right? And the final thing, when you're testing for soil, you also want to look for things that live inside of it. So bacteria, fungi, earthworms, those organisms that are found in there will make the soil much more healthy and improve the status of it. Okay. The last questions for this are going to be as follows. This is a check for your understanding because when you're looking at different types of soil, different plants grow better in those different kinds of soil. So for example, in question 1, corn is a crop that grows best in soil that drains well. Which of the following soils is best suited to grow corn? I'll let you look at the answer choices. And for question 2, a farmer is experiencing extensive crop loss due to high rains causing overly saturated soils. Which of the following approaches would best help the farmer alleviate this problem? I hope you guys were able to get those answers. I hope you guys learned something from this lesson. If you have questions, ask them in class, and I will see you in the next video lesson. Take care.